Okay, students, instructors, ladies and gentlemen, we're going to talk about the quadratic formula. I've developed this software to calculate the discriminant as well as the various solutions of a quadratic equation or within the quadratic formula. The quadratic formula is a solution in the standard form ax squared plus bx plus c equals 0 when a is not equal to 0 are given by the quadratic formula of x equal minus b plus or minus square root of b squared minus 4ac divided by 2a. The quantity under the radical sign b squared minus 4ac is called the discriminant of the quadratic expression. Ax squared plus bx plus c. It is used to determine the nature of the solutions of a quadratic equation. Here's the definition of a quadratic equation. Quadratic equation ax squared plus bx plus c equals 0 when a is not equal to 0 has the following solutions. There are three solutions. Number one, if b squared minus 4ac is greater than 0, then there are two distinct real solutions. X equals minus b plus or minus square root of b squared minus 4ac divided by 2a. Number two, if b squared minus 4ac equals 0, then there's one repeated real solution. It's x equal to minus b over 2a. Number three, if b squared minus 4ac is less than 0, then there are no real solutions. Solutions of a quadratic equation. Talking about the discriminant. How to determine the discriminant of a quadratic equation. Using the discriminant to determine the number of real solutions, or to not determine the discriminant of quadratic equation, but determine the number of real solutions of a quadratic equation. That's what we're using the discriminant for. Example, 2x squared minus 4x plus 50 equals 0. Using the discriminant. Solution. Number A. Or not number A, but A. Since A is equal to 4, B is equal to minus 20, and C is equal to 25, the discriminant is B squared minus 4AC equals 400 minus 4 times 4 times 25, which is equal to 400 minus 400, which is equal to 0. Discriminant is 0. Therefore, there's one repeated solution. Item number B. Now let A equal 13, B equals 7, and C equal 1. Thus, the discriminant is B squared minus 4AC equals 49 minus 4 times 13 times 1 equals 49 minus 52. It's equal to minus 3 because it's less than 0. And we conclude that there are no real solutions. It's less than 0. In standard form, the equation, item number C, in standard form, the equation is 5x squared minus 8x equal to 0. With A equal to 5, B equal to minus 8, and C equals 0. Thus, the discriminant is B squared minus 4AC equals 64 minus 4 times 5 times 0 equals 64, which is greater than 0. And we conclude that there are two real solutions. We'll demonstrate these solutions in a minute with some actual quadratic values, or plugging in the values for A, B, and C. The example of what we just talked about, broken down into one repeated solution, some information, definition on what that is, two distinct real solutions, and no real solutions. Look at the diagram here, the text of the results of a quadratic equation in the standard form. Ax squared plus bx plus c equals 0 when a is not equal to 0. It's given by the quadratic formula of x equal minus b plus or minus square root of bx minus 4ac divided by 2a. Calculation under the radical sign b squared minus 4ac is called the discriminant of the quadratic expression ax squared plus bx plus c It's used to determine the result of the three solutions of a quadratic equation. We're going to enter some quadratic values here, and we're going to click the calculate button to calculate our discriminant and our solutions. You can also, if we do not enter the correct values in, we can always click this clear field, and it will clear all of our value text boxes that are waiting for input. Quadratic value input. Okay, let's start with using the discriminant. We can use the discriminant to determine the number of real solutions of each of the following of these equations. Let's start with b value equal to minus 20, and then a, let's label that's input 4 there, and c 25. Once again, a is 4. They're all labeled here in this diagram of the quadratic equation, laid out: b, b squared, a, c, and a. Okay, what we're looking for now here is to find one repeated real solution, as well as the discriminant. There's one real solution here, okay, and we know that discriminant is 0. Okay, the roots are 2.5. Okay, now let's go and look at a case of there are no real solutions using a discriminant. Okay, let's plug in for b 7, and for a let's plug in 13, and c 1. And once again, a is 13. We click on calculate. You see that there's no real solutions here. Why? Discriminant is minus 3, and minus 3 is less than 0. Okay. Now let's look at one with two real solutions. Let's input b is minus 8, let's make 5a and c 0. And once again, 5a. We're looking for two real solutions, which means the value should be greater than 0. We have two real solutions. Good. Discriminant is 64, which is greater than 0. It's good. The roots are 1.6 and 0. Very good. Okay. Let's look at another value. Do a one repeated solution. Okay, and that is let's plug in for b minus 1, 2, minus 1, 2. Let's plug in 4 for a, and then c 9, and 4a. Plug in 4 for a again. Okay, we're looking for one repeated solution. One real solution. Very good. Discriminant is 0. No, there's only one repeated solution. This occurs because the discriminant is 0, and the roots are 1.5. That's the solution value. Okay, let's try another. Okay, let's look at a value that has a solution that has two repeated solutions. Okay, and let's use decimal points this time. Example, if you use non-numeric characters, this is what would happen in case you try to use the wrong values. Okay, let's look at some decimal characters, some decimal point values for the quadratic values. How about minus 197.6 and then minus 197.6. Okay. Oh, there's a mistake here. Let's go back. Okay. And then for b and b squared, 197.6. Okay, let's go to A. Let's go 16.3. Okay, and for C, we'll input 7.042. Okay, and 16.3, because A and A should be the same value, should always be the same value. They're labeled as well. Let's look at this in terms of two repeated solutions and see what the values are, what the product would be. Two real solutions as we anticipated. Discriminant is this number here, 38586.6216. Roots are the solutions, 12.08, no, we just round it up, 12.087 and 0.036. Just round it up. Okay? So I'll give you a whole number. You can round this up, anticipate rounding this up on your own. Okay, thank you. And this concludes this little software to describe and to calculate the quadratic equation based on the values you input, and to use the discriminant to find the solutions, various solutions to a quadratic equation or quadratic formula. Thank you.